Welcome. My name is Natasha Sherman, and I am your host. And my guest today is Dr. Peter L. Ward. Dr. Ward worked 27 years with the United States Geological Survey as research geophysicist, branch chief, and program manager. He helped develop and manage a major national research program, chaired a committee at the White House, testified before Congress, worked on the committee for Vice President Gore, published more than 50 scientific papers, and won 2 national awards for explaining science to the public. He retired in 1998, working intensely for the past decade, trying to resolve several enigmatic observations related to climate change. His analysis and theory are explained in detail on his website and his new book, What Really Causes Global Warming: Greenhouse Gases or Ozone Depletion. Welcome, Peter.
Well, welcome. Thank you.
So that's quite a history you have. And, you were retired and now you devoted 10 solid years to this subject. So tell us what compelled you here. What were the unanswered questions or the new questions that surfaced for you?
Well, about 10 years ago, cruising on the internet, chasing something totally unrelated to climate, I found data from the Greenland ice sheet, from a borehole that went down from Summit, Greenland, through the ice sheet. And in that borehole, you could measure the temperature at the time the ice was formed, and you could measure the amount of volcanism going on during that time. And what I discovered really amazed me. That was that at the end of the last ice age, when we warmed out of the last ice age, was precisely the time of the greatest volcanism observed in the Greenland ice. And I said, wait a minute, that doesn't make sense. What we know is that explosive volcanoes cause cooling. We observed that after all major explosive volcanoes, such as Mount Pinatubo in 1991, cools the Earth about 1 degree Fahrenheit for about 3 years.
Where is Mount Pinatubo?
Pinatubo is in the Philippines.
Okay.
And I said, well, this just doesn't make sense. But if I could understand this, it could be important. So I started looking at the data in much more detail. And I said, these data are good. And I realized back then that I was onto something. There was something going on here that just didn't seem right. And if I could figure it out, I might make an important contribution.
So I'm going to interrupt you here just for the lay people. And so typically, explosive volcanoes will cause cooling. And
Yes.
then you're noticing through the evidence starting in Greenland that there was warming.
Yes.
Okay.
And major volcanism.
Yes.
And what I discovered was that when you have basaltic volcanoes, this is a case like we see in Hawaii where the lava flows out over the land. When you have really big explosive basaltic volcanoes, that's when you get warming. And I discovered throughout geologic time, whenever there were major flows of basalt, we saw major periods of warming. For example, the medieval warm period started with major basalt flows in Iceland. The Roman warm period started with major basalt flows in Idaho. And so we see this relationship throughout geologic time of major basalt flows covering tens to millions of square kilometers or miles that they're associated with warming. So as I looked at it more carefully, what I realized was that what's really going on is that volcanoes cause depletion of the ozone layer. Volcanoes release bromine and chlorine that when it gets up into the stratosphere, depletes the ozone layer. Now, man did this accidentally back in the 60s when we started producing CFC gases. These were used as refrigerants, as spray cans for propellants, and so on. And what happened was, beginning in around 1970, the ozone layer began to be depleted. And as scientists looked at this, they realized that these CFC gases, when they get high in the stratosphere, can be broken apart, releasing atoms of chlorine. And one teeny little atom of chlorine can destroy 100,000 molecules of ozone.
Wow.
So when the Antarctic ozone hole was discovered in 1985, scientists said, oh my God, we've got a problem here. We got to do something about this. And within 2 years, working with the United Nations, they passed the Montreal Protocol on substances that deplete the ozone layer. This took effect in 1989. Well, sure enough, in 1993, the increase in CFCs in the atmosphere decreased.
Right.
In 1995, the increase in ozone depletion stopped. In 1998, the increase in temperature stopped. And so man seems to have turned on the ozone depletion and then to have stopped the warming and the ozone depletion. From 1998 to 2013, temperatures didn't change much. But in 2014, there was a volcano eruption in Iceland from Barðabunga that in 6 months covered an area of 33 square miles with lava. That's the size of the island of Manhattan. This was the most highest rate of basaltic volcanism observed since 1783. So it was a very significant event. And sure enough, 2014, 15, and 16 have been the hottest years on record. 2016 by far the hottest. And it appears that this is because of Barðabunga and the chlorine and bromine released by these lavas.
So what do other scientists say about this? Because we've been focusing on greenhouse gases. And
Scientists have focused on greenhouse gases since really 1859. There's a long history to greenhouse gases. And the scientists are pretty convinced right now that they are the cause. But one of the things I've found out in my research is there appears to have been a problem in how we calculate energy of radiation. And there was an assumption made back in the 1860s by one of the gods of electromagnetism, Maxwell, that electromagnetic radiation travels as waves through the atmosphere and through space.
Right.
Well, it turns out if you calculate in terms of waves, you calculate energy of those waves in a certain way. But what I realized was, no, that's not what's happening. What's actually happening is electromagnetic radiation, which is a whole lot of different frequencies, are traveling through space and air as frequencies. A radio station transmits the frequency. A radio receiver is tuned to pick that frequency, and that's what's communicated between the two. And when you realize that it's frequency that's being transmitted, not waves, you calculate energy in a way that makes a whole lot of sense. And what you realize then is that the effect of the energy that reaches Earth when you deplete the ozone layer is 48 times hotter than the energy that reaches the Earth when greenhouse gases absorb infrared radiation.
So I'm going to stop you here because we're focusing in one area. What happens if we continue focusing there? Is anybody paying attention and saying, wait a minute, we need to shift gears here. We need to point ourselves and look in a different direction?
I'm having a very hard time getting people to take that step. They are so convinced, based on their consensus, that greenhouse gas theory is correct, that some of the top climatologists in the world are saying to me, look, Peter, there is just no way that you could be right and everybody else is wrong. And I said, well, give me a scientific reason. You know, it was Michael Crichton, the author of Jurassic Park.
Yeah.
He said, look, if it's consensus, it's not science. If it's science, it's not consensus.
Yeah.
The most famous scientists in history are famous precisely because they broke with a consensus. So over a year and a half ago, I issued a challenge to over 2,000 climate scientists, all the scientists that wrote or reviewed the recent IPCC technical report on climate change. And I said, look, we've never done an experiment that shows that greenhouse gases actually cause warming of the air. That experiment needs to be done. And I'm offering $10,000 from my children's inheritance to the first scientist that can do such an experiment successfully. Because I am convinced, from my understanding of the physics and from the data that I'm looking at, that greenhouse gases do not cause significant major global warming.
And did anyone take you up on the challenge?
No one's picked me up on the challenge. I've followed that with many other things. I've talked to many of the top climatologists in the world. I am continuing to try to get the word out there because the reality is, since the Paris Accord, we're now agreeing to spend more than $10 trillion to reduce greenhouse gases. And if I am correct, then that is a total waste of money.
Wow. So a bunch of questions surface. Okay, so let's say that we continue on the path we are now, and the ozone layer continues to be depleted, and we have global warming. What could we do if the cause of the global warming is a break in the ozone layer due to volcanic activity? I mean, can we control that? What are the possibilities?
No, we can't control volcanic activity, and there are 4 volcanoes in Iceland right now that are looking like they may become much more active. And if they do, in history, they've been significant eruptions. But we can, what we know is that the world is not likely to get warmer now unless we have more volcanic activity.
Okay.
So the projections that are made by climate models at the moment that the world is going to get hotter and hotter over the next century just do not stand up at this point. And in fact, climate models have not predicted the temperature correctly since 1998. So there's no reason to really trust those models. What my work shows is that there is very good reason that the mathematics in those models may not be correct, that we're not calculating energy properly.
So then, again, we go back to, okay, so if you're right, what should we be doing?
If I'm right, what we can do is continue to burn fossil fuels, provided we control pollution. You know, currently in Southeast Asia and China and Asia, we're killing over 3 million people a year because of pollution. But we know how to control pollution in the Western world. And if we control pollution, we can continue to burn fossil fuels.
Wow.
In terms of controlling the climate, there's not a lot we could do, but we should be doing research on that. What can we do to maybe help the ozone layer not get depleted? Now, the problem is we did deplete the ozone layer. It remains depleted at this time. And these CFC gases are very stable and they last for a very long time. So we do not expect the depletion to reduce significantly for several more decades. As long as we remain depleted, more ultraviolet B radiation coming from the sun is reaching Earth and warming the ocean and melting ice. So much of the effects of warming that we're seeing is going to continue, and there's not much we can do about it at the moment.
So it sounds a little doomsday-like.
Well, not really, because the doomsday is this conjecture by the majority of scientists that we're going to have major warming in the next many decades. I mean, what we're seeing now, the Earth is not likely to get warmer now unless there's a major volcanic eruption, basaltic eruption. So that really is good news. The fact that we can burn fossil fuel is good news. Our lifestyle depends on major amounts of energy. And as the rest of the world becomes more highly developed, they need that energy too. It also means that we don't need to spend trillions of dollars reducing greenhouse gases emissions, because that could be, we can use that money for a lot of other things.
Yes. Yeah, and again, no, the doomsday for me is the whole thing of, well, we can't do anything about the volcanoes, and if they erupt, and whatever the consequences of that are, it's just the way it is.
Well, in geologic history, we see all kinds of volcanic eruptions. There was one 251 million years ago where lava came out and covered an area of Siberia equivalent to 87% of the United States. Just imagine basaltic lava all the way from New York to San Francisco to Seattle to Miami. This was the largest eruption of lava at that time. It was the greatest mass extinction at that time. The world got extremely warm. Over 96% of all species in the ocean were killed. This was a major event. We see several dozen of those events, not quite that big, throughout geologic time. They occur on average about every 22 million years. Now, the good news is they haven't been around for a while, and we don't expect them for a while. But if any of the major basaltic eruptions that have occurred in written history were to reoccur now,
yes, we
would see the effect. It would change climate. We would survive it. But the climate will change. And we've seen the climate change. We can record climate change throughout geologic time and throughout written history.
Wow. And can you say a little bit about the relationship between earthquakes and volcanoes?
Well, that in fact was my specialty with the U.S. Geological Survey. And what basically, when you crack the earth and you let magma come up, you get a volcanic eruption. And when you crack the earth, that's done in earthquakes. And what we notice now is that when there's a significant increase in earthquakes, say before the Mount Pinatubo eruption in 1991 or before the Barlabunga eruption in 2014, we see the magma coming up to the surface, and we can actually trace the earthquakes, and they become much more numerous and very active, and then we get a big eruption.
So, from the things that I read, and I know they are, developing ways and have developed ways to predict earthquakes. Has that shown up in how people are prepared now, how buildings are built, and in preparation for, let's say, if there is an earthquake, preparation for volcanic eruptions?
Well, a major national program that I was in charge of in the 1970s was the attempt to predict earthquakes. And at that time, we saw many physical changes that could occur months before an earthquake. And we in the United States, the Soviet Union, China, around the world, there was a great deal of interest that earthquakes might be predictable. It turned out that we just can't get adequate data to really show that. And we decided finally it was much more important to improve earthquake engineering to make our infrastructure more earthquake resistant than to try to predict earthquakes. On the other hand, predicting volcanoes, we've gotten pretty good at it. We actually predicted the Mount Pinatubo eruption in time to get people out of the way. Millions could have been killed if that, certainly tens of thousands could have been killed if we had not predicted the Mount Pinatubo eruption. So in volcanic eruptions, as I say, we see this increase in earthquakes. We see an increase in the swelling of the ground and the deformation of the ground. And we're getting pretty good at predicting that.
Wow. So what were some of the, you couldn't ultimately hang your hat on it, but what were some of the signs that were seen that were signs of an impending earthquake?
Well, an earthquake is a case where you deform the ground and then it suddenly snaps. Okay, so there are many ways of measuring this deformation. Now, back in the 70s, it was very difficult. Nowadays, with GPS, we can measure it in great detail, and it will work a lot better now. But you can see deformation of the ground prior to the earthquake. You can also see changes caused by that deformation. For example, the water table seems to have changed. The Chinese actually predicted an earthquake in Haicheng in 1976 by the fact that snakes came out of the ground in the middle of the winter. And they explained this by the fact that the ground was being deformed, the water table went up, this warmed the frozen ground near the surface, and the snakes said, oh, it must be spring.
Wow.
And in that case, they actually convinced people to stay outside of their buildings on a specific day.
Really?
And they actually showed movies outside. And when the earthquake happened, many less people were killed.
Wow.
But we haven't been that successful in all cases. There are other evidence of small changes in the amount of radon coming up through the ground. Many, many different physical things that we could measure. There's been a lot of effort in China trying to correlate animal activity and sensing with earthquakes. None of it's been particularly convincing, but there was a big effort. But at this point, as I say, most seismologists are not working on earthquake prediction. They're working on trying to understand earthquakes in greater detail as to where they occur and why they occur and when they occur. But we've kind of given up at the moment, at least, till we get better data on predicting the time that a specific earthquake will occur.
Right.
Now, we did predict back in 1990, following the Loma Prieta earthquake in 1989 in San Francisco, we predicted in 1990 that within 30 years, there was a 67% chance of a major earthquake occurring in the East Bay, going through Berkeley, Richmond, Hayward, throughout the East Bay. And that if that earthquake occurs, it will be the biggest earthquake the most damaging earthquake in U.S. history. We've now gone 27 years since that prediction.
Wow.
We don't call it so much a prediction as a forecast that, it could happen. We're not predicting the specific event. We're just saying it is going to happen. We're certain that event will happen. And we're getting the likelihood of it happening has increased significantly in the last 27 years.
And are any actions set up to, alleviate what might occur?
There's been a great deal of effort in preparing the Bay Area so that it's not as heavily damaged as it was in the Loma Prieta earthquake. But the difference is the Loma Prieta earthquake was 50 miles south of San Francisco. This one will be right through the football field at the Berkeley Stadium.
Wow.
I mean, it's right through the Eastern Bay.
Would you live in San
so
Francisco?
Disaster planners have taken this into account, and the building codes now in the Bay Area are much more persistent. There is an understanding this could happen. Back in 1990, I published a magazine, 26-page magazine, sent to 3.3 million families in Northern California, explaining what could happen and what you could do about it, how you could prepare for it.
Wow.
That was featured on Good Morning America, and we got 50,000 requests for that magazine from around the nation to get that information.
So just knowing what you know, because people move to California and they know that these things can happen, but they kind of figure in somebody else's lifetime. So knowing what you know, would you live in San Francisco at this point?
Well, I did live in San Francisco for 27 years.
Okay.
Or in the San Francisco region. I moved to Jackson Hole, Wyoming, and the Grand Teton mountains here are very steep-sided on the east side, and the reason is that they go up in earthquakes. And a magnitude 7 earthquake along the base of the Grand Teton and the Teton Mountains would be devastating in the place I'm living. I mean, I look right out my window at that.
Wow.
So the fact is we live where we live for various reasons, and no matter where we live, there's some hazard. It could be tornadoes, it could be hurricanes, it could be earthquakes, it could be volcanoes. So what's important is to be aware of the hazards where you live and to be prepared for them, to think about what you would do if they occur. For example, if we get a big earthquake on the Teton Fault in January in Jackson Hole, Wyoming, we're in deep trouble because we could lose power. We may not be able to get out of any of the passes or canyons that connect us to the rest of the world. We may be on our own for weeks, and it might be 20 below zero outside.
Wow.
So it's only wise to be prepared for that possibility.
Yeah.
And one of the first things I did when I moved to Jackson was to write a preparedness brochure pointing out that fact, that these are the various hazards that we face. This is what the effects of those could be. And this is what we ought to do to prepare for them so that we don't have, also we reduce damage as much as possible.
And was that welcomed, that information?
It is welcomed, and we now have a system run by the local emergency management that can notify any of us on our cell phone immediately if there is any hazard that is showing up. And in fact, that was the committee at the White House that I chaired many years ago, was how to get warning information to people no matter where they are, no matter what they're doing. And right now, FEMA has a program where it can send a message to your cell phone if you're in the region of high risk without even knowing your cell phone number, just by the fact that you are being served by a tower in the region.
So we have about 2 minutes left, and I want to give you an opportunity to say whatever it is that you think is most important for us to think about.
Well, I think my major contribution to climate change is that it appears that ozone depletion is responsible for the warming aspects of climate change caused by CFC gases or by volcanic eruptions, basaltic volcanic eruptions, and that explosive volcanoes are the cause of cooling in climate change. This makes a big difference compared to what the consensus is at the moment about greenhouse gases. We don't need to spend trillions of dollars reducing greenhouse gases. That would be a total waste of money. Now, the problem is right now, there is a consensus, but science is not done by consensus. Science is done by data, done by analysis. And it was Michael Crichton who said, look, if it's consensus, it's not science. If it's science, it's not consensus. The most famous scientists in history are famous precisely because they broke with the consensus. Right now, it's Peter Ward against the world. And I'm working very hard to get the word out that there really is a misunderstanding here about climate change. I'm talking to the top scientists in the world. I'm trying to get them to understand it.
One would think that all the people who are profiting from fossil fuels would jump on this bandwagon.
Well, it's very interesting. I assumed initially that many of the skeptics that don't believe in climate change would be very interested in what I'm saying.
Right.
I am talking with them. Some of them are sort of interested, but they all have their arguments. You know, for 2 decades at least, we've been arguing ferociously back and forth between the believers and the skeptics. And
right.
And it's gotten very, very bitter. There's been a lot of ad hominem attack. There's a lot of sore feelings. There's a lot of people that are very frustrated. And most of the scientists are frustrated in dealing with people that they don't think are even understand the science.
Right.
And so I'm walking into a battlefield that is a pitched battle.
Yeah.
And it's amazingly difficult to get people to say, well, just slow down here, man. Look at this, look at this, look at that. That suggests we've got a problem. Let's at least talk about it.
Yeah. Peter, we're at the end of our time. Thank you so much for doing this interview. Good luck. Again, I think people might be interested in maybe even kind of pursuing it with you. So I appreciate what you're doing. And since we are all at the effect of global warming, it impacts all of us. So thank you.
It's all discussed on whyclimatechanges.com.
Great.
So people can get all the detail they want there, or in my book, What Really Causes Global Warming.
Wonderful. Thank you. And that will be up on the screen as well. My name is Natasha Sherman. Thank you for joining us.